Hey guys, I'm Mr. C. Welcome to today's lesson on functions and graphs of functions. As you guys can see, these types of questions, you will see these types of questions are all over the MCAS and all over probably any standardized high school math test. So um, anyway, if you're preparing for the MCAS or any other standardized high school math test, you are in great place to be right now. So yeah, let's get into it. Um, now, you guys remember from today's warm-up, those of you guys that were in class today, right, 1 and 2 looked very similar. In fact, you could argue they're the exact same problem. The reason we put this one up here is because we want you to understand that y and f of x, really the same thing. F of x is just a fancy name for y. I guess, I don't know, the reason high school teachers do this, maybe it's to make things confusing, or maybe it's because in many cases, as the math gets more advanced, there's more equations that need different names. So you can't just call everything y. You know, you're going to go with f of x, g of x, h of x. For all those of you that have taken algebra 2 or algebra 1, no. So anyway, yes, it's true. You get the same exact answer right here. Y equals 3 times -1 plus 5. What's that? -3 plus 5 gets you 2, right? And here, the exact same problem. All you're doing, you're just plugging -1 in for x. And basically, that's what that function notation is telling you. All right, evaluate the function here. Data tables. I think that the title of today's lesson is functions and graphs of functions. There's kind of a third brother or sibling, I don't know what you call it, third part to it, which is data tables, right? You're going to be able to deal with equations, graphs, and data tables. This is an example of that. Basically, we just plug in -1, right? 4 times -1 minus 2, what is that? -4 minus 2, which I believe is -6. You guys could check my math on this. Here, plug in 0, 4 times 0 minus 2 is -2. And plug in 4 times 1 is 4, minus 2 is 2. So anyway, that's how your data table should have looked. And here, asking you to evaluate the function. Again, why do we have these? Basically, it asks you to do the exact same problem because we want you guys to understand the connection between these function equations. F of -1 just basically means you're sticking in -1 for x, right? And yes, you're going to end up with -6. Right? F of 0 basically means you're just sticking in 0 for x. 4 times 0 minus 2, right, is going to be, yeah, -2. Right? And then here, sticking a 1, 4 times 1 minus 2 will get you +2. So yes, 3 and 4, basically the exact same problem, just in different ways, much as 1 and 2 are the exact same problem, represented in different ways. And another reason we did this, you guys, is because what most students figure out with all this function stuff is that typically it's not the math that's the hard part. It's the way that it's represented is intimidating. So function notation scares students, but when you really understand what it's saying, right, that all you're doing is you're plugging this number in for x, it actually, the math is relatively simple, right? And now, what vertical line tests, which are functions, graphs of functions, and which could not be graphs of functions. So what makes a function is that any value of x, there's only one value of y that could correspond with that value of x, or only, I guess, one output for any particular input, I guess. So I guess the reason why this vertical line test works, right, and basically what it is, if it's a function, there should be no point in the graph where if you stick a vertical line through it, it would intersect in 2 points, right? Because every x can only give you one y, right? So this would not be a function because if you said, well, hey, if x is 5, well, y could be either 2 or -2. No, that would not be a function. Same thing here, graph of a circle. Graphs of circles are not functions. Here, right, and all you need is one vertical line that you could pass through the graph, and if it's going to intersect at more than 1 point, it is not a function. Okay, so that is one very quick and easy way to understand or to figure out whether a graph could be a function or it is definitely not a function. I know you guys did this in Algebra 1, so I'm moving along here, right? And so this is actually an MCAS question that is asking you to use the vertical line test. Which of the following graphs does not represent a function? Y is a function of X. And let's see, well, there's no vertical lines through A, no vertical lines that can pass through B, but or C, but D, right? Yeah, no way. D is not a function, right? Some people might ask, well, hey, how come B is a function and D isn't a function, even though it's kind of like B sideways? Well, actually, this is totally legit because it's cool if you have a Y value that 2X values could get you the same Y value. That's cool, right? As you guys know, with a quadratic equation, or quadratic function, that's what you will have. But the other way around is not okay if you want to have a function. Okay, so this is the old way and the new way. Basically, this is just demonstrating to you that in Algebra 1, right, or pre-algebra, right, all we did, we had Y's and X's, right? Now we've got this fancy function notation. But if you look at it, really, all it is, f of X is just a fancy name for Y, right? And f of a number is just saying plug that number in for X, evaluate it, see what you get. So anyway, the other language that tends to be used, input and output, right? So in this case, your input was your X, right? Your input was your X, right? And the output is whatever you end up getting, right? Whatever you get here, or also known as f of X. All right, so consider this function. Another real MCAS question here. I don't know, this was on your practice MCAS or something published by the MCAS test makers, but official MCAS question here. What are the values f of 0, f of 5, f of 18? I understand how this could be an intimidating question, but all it's saying is, well, what happens if you plug in 0 for X? So if I make this 0 and this 0, right, I get basically 0 times 18. This is going to be 0. Here, if I plug in a 5, right, 5, right, it's a little more like 5 times 13, right, should get you, I think, 65, right, so that will get you 65. Here, if we make it 18, actually, this is also a layup because 18 minus 18 is 0, right? So anything times 0 is also going to be 0, right? So this is going to be 0. So let's see if any of these match, right? F of 0 is 0. Okay, so this is automatically wrong. F of 5 is 65. F of 8, hey, here we go, right? And here's another thing. I know this isn't just about math. This is also about getting good at taking these standardized tests, right? Remember, process of elimination, right? If the only thing you know is that when you plug in X and you multiply by 0 to get 0, right? That's the only thing you know, right? You could still eliminate A and D and make it a 2-horse race, right? And then if the other thing, if you didn't, f of 5 kind of confused you, but you recognize here, oh, 18 minus 18, that's 0, right? So again, I'm multiplying by 0, right? Then you didn't really do much math and you got both of these right without even having to multiply anything real. Okay, anyway, any chance I get to talk about the test taking strategies, I'm going to take it. So, hey, if you don't like it, just, hey, skip ahead to the next problem. Okay. Now, this is where things get a little more confusing because you're not just plugging in numbers, right? You're plugging in variables, or in this case, a variable expression. So what you have to do here, f of m plus 2, what we're saying here is that everywhere we see an x, right, we're going to stick in an m plus 2, right? Okay, so that might not be too complicated, but what students want to do is they want to skip steps, right? The only way to square a binomial, right, and you guys that have been in Algebra 2 or many of you Algebra 1 students as well know all too well, you cannot get lazy when squaring those binomials. You've got to FOIL that thing out, right? We got m squared, right, outside, what's that, plus 2m. I'll do this a long way so you guys can kind of see everything. We'll kind of combine like terms at the end. The last, right, plus 4, right, plus 1. Okay, so here I'm combining like terms, m squared plus 4m. Check my math, you guys. Plus 5. Okay, let's see if that matches. Okay, that matches D. Yeah, I mean, and that's kind of all I got to say about that, right? I kind of did it out the long way. I showed you the algebra, um, and that's that. But just, yeah, that's just something to be aware of, right? F of anything, you're just plugging that thing in for x, even if that ends up being a variable expression like you see here. Okay, another official MCAS question, right? The function g of x is represented by this equation. Okay, all right. All right, which of the statement correctly compares the rates of change, the y-intercepts are f of x and g of x? Okay, so this is a little tricky here, right? We've got a f of x equation and we got g of x equation. Okay, so so this is kind of straightforward. They tell you that the slope and the y-intercept, right? You guys remember from our last lesson, right? Is all about y equals mx plus b in a million different ways. This is kind of no exception, at least with g of x. But since they're telling us that f of x is also a linear function, right? Well, then we also get a y equals mx plus b. Now, what you might want to do is you might want to just write what that function is, because I know the y-intercept is 120, right? I know because if x is 0, f of x is 120. So that's your y-intercept right there. That's what it means, right? Now, the next thing, getting the slope might be a little more of a challenge, right? So maybe I take these 2 points here and I use the slope formula, right? So I got my change in rise, or the change in f of x, or the change in y, right? For those guys of you like more familiar with y than f of x, which is the majority of you, over the change of x, right? And so what you've got there is you got 30 over 20, which can be reduced to 3 halves, or 1.5. Okay, so I'll call that maybe 1.5. And let's see what these answer choices are giving us here. I'll just write that out, 1.5x. Which could also be 3 halves, as I said before, right? So the function f of x has a greater rate of change. Oh, you know what? Let's see. Oh, you guys. All right, catching my mistakes here, right? Okay, yeah, it's true. Mr. C made a mistake. This is negative 1.5, right? You guys know I did the oldest trick in the book there, right? I flip-flopped the x and the y. Big mistake that's going to get to the wrong answer, right? And the reason I caught it is because I noticed, hey, wait a second, x is going up, y is going down. This should be a negative slope, right? So something was fishy when I saw a positive slope. So anyway, please forgive me, you guys. I don't know, maybe that was a legit mistake, or maybe I was just trying to make a creative way of proving a point there. Hey, either way, you believe what you want to believe. But anyway, there's a negative slope, right? So here, let's go through our answer choices. Function f of x at a greater rate of change and a greater y-intercept. Well, it's got a greater y-intercept, but not a greater rate of change. So I'm going to, boom, A is out. Function g of x has a greater rate of change and a greater y-intercept. Well, has a greater rate of change, but not a greater y-intercept. So that's out of there. C, function f of x has a greater rate of change. And function g of x is a greater y-intercept. I don't think either one of those things are right. Uh-oh. Oh, D's right. Function g of x has a greater rate of change. Okay, that is true. All right. And function f of x has a greater y-intercept. That is true. Bingo. We got ourselves a right answer. So that was tricky, right? You had to deal with equations. You had to deal with data tables. I mean, probably the best way to do that is to actually make the equation, so you're comparing equation to equation. And again, I mean, this could be a continuation of our last lesson, because you guys are just seeing y equals mx plus b is everywhere. Word problems, function problems, graphing problems, right? So if all you know in math is y equals mx plus b, hey, you know a lot. And you're going to be able to solve a lot of problems in your math class and on the MCAS. Okay, all right, what is this? Is this a, okay, this may have been a two-part problem, but maybe we're only asking you to do the first one right now. The table shows a linear function. So again, a linear, right, that's code for y equals mx plus b, or in this case, f of x equals mx plus b. A student graphed the line that represents f of x on a coordinate plane. Which statement about the graph f of x is true. Okay, well, let's see. I mean, I could kind of talk abstract, right? As x is getting bigger, f of x is getting smaller. So there should be a negative slope, should be a negative rate of change, right? So right away, these two that say the slope is positive, automatically wrong. The other thing conceptually, right, if it's going down from 223, right, well, 0 would have to be even bigger than 223, so that y-intercept would definitely be positive. So anyway, that is the right answer. Now, those of you guys that are not satisfied with my logic, that's cool. You could go flex your algebra. You could do that, right? What we could do here is we use our rate of change, right? I'll just use these 2 points here, right? So we got 206 minus 223, right, over 4 minus 2, right, using that slope formula. What is this? Negative 17 over 2. That is a negative slope, right? Now, of course, you guys want that y-intercept. How do you do that? Well, again, we make our money on y equals mx plus b. Now, again, you don't have to do this, right, if you already got the solution, but some of you guys may want to. If you want to figure out that exact y-intercept, right, basically what you got to do is plot a point. I kind of like, you know what, I like this one. I like this one, right? It's got kind of, you know, smaller numbers. So y is 223, right? Remember, f of x is just fancy name for y. Slope negative 17 over 2. Okay, your x is 2, right, plus b. Okay, now we do our algebra. 223 negative 17, because I'm just kind of multiplying across, plus b, right? And then add that. Looks like b, you had 17 to both sides. B should be 240. Anyway, you didn't have to do that algebra, but if you wanted to, right, that is how you would have done it. So we got our slope, which is negative 17 over 2. And we've got our y-intercept, which is 240. Right? So again, B is the only one that satisfies that with the negative slope and the positive y-intercept. Okay, IXL preview. You guys notice, I think we gave you a bunch, but they're kind of quick, right? I mean, basically identifying, is this a function? And the way you know is that, well, if an x value, and we'll call this, you know, I'll call this x, we'll call this f of x, right? You know, if you want to call this x and call this y, sure, right? But you could not have 1x getting you 2 different y's, right? So as far as we know here, right, where each x only gives you 1 specific y, right? As far as we know, that would be, that could be a function, right? Now, for the graph here, right, if you're looking at this, well, remember, what makes it a function, right, an x can only get you 1 answer for y. You show 1 place where that's not true, using the vertical line test, right, we're talking no way could that be a function. Okay, and you guys have a couple practice ones on the IXL, right? Once you guys get this, you get it. You know, and then we a little more complicated, but again, it looks complicated, but the math actually is relatively simple. All this is saying here is just plug in 11 for x. That's all it's telling you to do, right? So you plug in your 11, right? What's that? Negative 77 plus 12. I don't know. Check my math, you guys. What is that? Negative 65. I don't know. Maybe I got that right. Maybe I didn't. But that's how you do it. You plug in your 11, right? And then you just do the math. Right, and here, use the graph f to find the solutions. If f of x is 0, so in other words, y is 0. Okay, so here y is 0, right there and there. So we've got 2 solutions, right? We could have 4 and 10, right? So you see what we want you to do. We want you guys to be able to deal with functions, the graphs of functions, data tables of functions, and equations of functions, right? Doing all 3 of those things, right? That's kind of, you know, when you know you really got a handle on these function questions. Okay, again, here, this is a data table, right? All you're going to do is just, you know, plug in your x, see what you get for f of x, right? 1 minus 4, negative 3, the absolute value, right? The absolute value of negative 3 is just 3, so there's your answer there, positive 3. here, right, again, just they're asking you, giving you the graph. All you got to do here, this is a lot easier than it looks. Hey, if x is -9, what's f of x? Oh yeah, hey, it's 8. There we go. Oh hey, if x is 2, what's f of x? Oh, it's 0. Right? Hey, if x is 9, right, what's f of x? Looks like it's what, -3. Right? That's all that's asking you to do is just find a point on the graph and just what is the x, y, or the x, f of x pairing for that. Right? So there's your IXL preview. And the homework assignment, we want you guys to try these MCAS questions. These are all official MCAS questions. This one, and obviously it's your homework. I don't want to steal your thunder and go over it, but really, right, what's this asking you to do, right? Actually, if you're worried about me stealing your thunder, just stop the video and do the homework, right? I mean, that's a simple way to do that. But hey, f of 4, basically, what's x or what's y if f is 4? Oh, here we go. I don't know. Looks like it's 2. Okay, this one's a little trickier because it asks you to do, well, it says, well, f of 4. So first of all, you got to figure out, what is f of 4 in the first place, right? F of 4, oh yeah, we figured out it was 2, right? So 2 plus k is -5, right? All is, right? It's code for an equal sign. It is code for set up an equation, right? And you guys, I mean, everyone in the room knows how to solve this one, right? You just subtract 2 from both sides, and what's k equal? -7, I think. I believe so. I don't know. Check my math on that, you guys. But yeah, so the hard part really was just recognize, well, f of 4 is just a fancy, intimidating way, right, to just say 2, really. Okay, this is one I wanted to go over, because what's going on here if we add 3? Okay, so what adding 3 to f of x does, right, is it basically just shifts the whole graph up 3, right? And now what happens here, and this is kind of counterintuitive. I mean, you guys all kind of knew that, all right, you add 3 to the whole thing, it just kind of shifts it up 3, right? 1, 2, 3, right? You knew that. Right? You guys all knew that, right? But then, so that one would kind of look like, like this. And I'm just kind of doing a rough sketch. Right? But what does this do, right? What happens when it's inside the parentheses, right? Now, what I do, this is my way of remembering, right? I say, 0 this thing out, right? What plus 3 equals 0? -3, right? And that would tell me I'm moving over 3, 1, 2, 3, in this direction. Okay, because that's, people get this so confused. So it's like plus means move to the left, and then minus says move to the right. Well, you get it flip-flopped and confused in your head. But here, just thinking to myself, right, well, f of 0, right, if x was 0, it would just kind of stay the same. So plus 3, how would I zero it out? Well, I got to move it over 3 in the negative direction. Anyway, maybe that helps you. Maybe it doesn't. Maybe you just want to say, hey, plus 3 means move to the left. -3 means move to the right. Sure. If that's how you do it, that you remember that rule, then by all means, remember that rule. Okay, and then this is one that asks you to do kind of 2 things. Actually, excuse me, 3 things, right? So this means you shifted up 1. And by the way, this is kind of a little more advanced, right? So you guys probably, unless you took Algebra 2, may not know this, right? This would mean shifted over to the left 2, right? Shifted over to the left 2, right? Because you're zeroing this out, right? And this means flip it upside down, right? So whenever I have a problem like this, what I do is I start, in this case, a quadratic. So I'm going to start with a vertex, right? I'm going to move it up 1. I'm going to move it over 2. And then I'm going to flip that thing upside down. And of course, they want you to do it on this graph. So I guess you just kind of transfer your work over, right? Anyway, that was kind of advanced, right? That might be something you want to pause and rewind a couple of times. But basically, adding something to the entire function, right, kind of like the loose change, right, makes y bigger, right? So it just pushes it up, right? If you've got something going on with the x, basically I say just zero it out, and it'll tell you whether you move over to the left or the right. And then, you know, if you have a negative, think of what that means. You're multiplying the whole thing by -1, which basically means you flipped upside down, right? Hey, if I stole your thunder by going over some of the homework, I apologize, but I feel like this is kind of advanced, right? So I wanted to just kind of clarify it so you guys would not be confused. Hey, that concludes it. That's it. That concludes our lesson and the homework, really, except, of course, you still got to do those IXLs on your own. Again, I'm Mr. C. I look forward to seeing you guys tomorrow in class, and I appreciate you watching this video.